Alrighty, so let's start. So remember we were dealing with the profit maximization problem, right? And so we saw the cost minimization problem, and then we said that, but the actually firm's real problem that we were talking about was profit maximization. And then we actually said that, so this was, so profits, we said that it was a function of quantity. This is, like total revenue, which is a function of quantity, and total cost, right? So we know how to get the total cost function, right, from the cost minimization problem. And then we actually started dealing with the profit maximization problem, okay? And then you said that, so when you, first of all, remember, was this a constraint or unconstrained maximization problem? Unconstrained, right? So this was an unconstrained maximization problem. So you basically have this, right? And then you wanted to find the optimal, right? So the profit maximizing quantity for this firm. And then when we, right, so for the maximization, what do? We take derivatives and then set it equal to 0, right? And we said that the condition, the necessary condition is that at the profit maximizing quantity Q star, marginal revenue should be equal to marginal cost, right? Bless you. So, and then we said that, but this is not enough, right? So we said that this could well be the condition for the minimum profit as well, right? So then we said that we should check what? Right, so we should check the second derivative. So this one is, we said that the profit maximizing at profit maximizing Q star, this was the condition, right? And then we also had, so at the profit maximizing Q star, this was the condition. And we said that we should check the second order condition as well. And then we said that this was basically looking at the second derivative, and this was, we said that it should be less than 0, right? Because it's a maximum, so we require the objective function to be actually concave, right? So that's such that the maximum exists. So this is the case, but let me ask you this. What do you think this corresponds to? This goes very back to the very first lectures that we had in this course. So, for instance, suppose the firm is a price taker. A firm being a price taker, it means that by producing or selling, like more or less, they won't be able to affect the price, okay? So if the firm is a price taker, we write basically profit like this, P times Q. So this P, price, is not a function of quantity, okay? And then, so this is minus total cost, this. So when I take the first, suppose when I take the first derivative of the profit function, what is it? We set it equal to 0, basically. But when what is this? So this, you make it equal to 0, right? With the profit maximization condition. What is it? Take the derivative with respect to Q. Right? This is P minus, what is this? The derivative of total cost with respect to Q. What did we call this guy? This was called marginal cost, right? So this was basically marginal cost. So, and first order condition, right, requires this, if it's a profit maximizing point, this should be equal to 0, right? So if the firm is a price taker, you see that the condition is that price should be equal to marginal cost, okay? Now, what about the second derivative? If you want to check, so this was the first derivative. If you want to check this guy, val Q star. So basically it means that I'm going to take the derivative of this with respect to Q again, right? And what is it? Minus. Right, so this is basically the derivative of the marginal cost. So we said that if it's the profit maximizing point, this should be less than 0, right? And then what does this mean? It means that, what does this mean? It means that marginal cost should be, or the derivative of the marginal cost should be positive. What does this mean? It means marginal cost should be increasing, right? So you see that marginal cost should be increasing. So you see that this is basically, so just keep this in your mind, okay? So you see that marginal cost at the profit maximizing Q star, apparently marginal cost should be on its increasing portion, okay? So just keep this in your mind when we draw some graphs. This is going to be, you'll understand why this is important, okay? But it means that apparently, right, for the profit maximizing firm, it means that your profit maximizing quantity should be on the increasing portion of the marginal cost, okay? So this is what we will see later, so just keep this in your mind. But we said this is easy, right? So compared to the other constraint optimization problems that we solve. Now, we said that we call this portion, right, the derivative of total revenue. So how did we call this? The derivative of total revenue with respect to Q. How did we call that? We called it marginal revenue, right? So this was called marginal revenue. And remember, we started dealing with the marginal revenue. Then basically, we actually said that if I sell one more unit, right? How will that contribute to my output, right? How much will that contribute to my total revenue, right? So if I'm going to produce one more unit of output, or if I'm going to sell it, how much will that contribute to my total sales, basically, okay? Total output, total revenue. Sorry, total output is this, okay? So that's what we call, that's what we said about marginal revenue. And then remember, we wrote marginal revenue like this. We said that marginal revenue is basically, and because it's just a function of Q, I can write it like this, okay? So we actually said that D total revenue, we know that total revenue is PQ times Q, right? And then we said DQ. And then we actually said that this is PQ, right? We did this in our previous class. Plus, we actually said that, right? So then times 1. And then we had del PQ, or D, let's put it DP, DQ times Q, right? And then we take it into the PQ parentheses, 1 plus DPQ, DQ, Q over PQ. And then you told me, Hocam, this is what? So you said that, Hocam, this looks like what? 1 over elasticity, right? So it looks like elasticity. It's actually 1 over elasticity. So let's put it QP, okay? So this is basically the case. Now, so this is actually, right, so I put this. So then it turns out that we can write marginal revenue like this, okay? So this is PQ and 1 plus 1 over QP. Remember when we defined elasticity, we used XPX. So here, instead of X, we're going to use quantity and then price is there, okay? So this is actually another way of expressing marginal revenue. Now, for instance, what can we say about marginal revenue? You told me that, Hocam, this guy, you can either look at here or look at here. You can say that, Hocam, this guy is except for which goods? This is negative. Inferior or which goods? Given goods, right? So remember, like given goods were also inferior goods, but not all inferior goods were given goods, right? So basically, this guy is negative, so, and then this is positive. Then we said that marginal revenue is always below the price, right? If you have actually a demand curve, which is a function of Q, okay? So basically, you can see that here. So elasticity, as long as this is negative, we know that elasticity is negative. So this is going to make definitely marginal revenue below price, right? Now, what else we can say here is that, let me write these down. So let's actually have this. Now, let's actually have these. So let's try to figure this thing out. What's going on? So, for instance, suppose I have elastic demand. Okay, then what is that elasticity? Suppose demand is elastic. So let's write this down. But let me actually ask you this: if the firm is a price taker, then what do you think? What's going to happen? If the firm is a price taker, what does that mean? Whenever Q changes, right, it's not going to affect the price. Then this is going to be what? 0, right? And then what's going to happen if this portion is 0? Marginal revenue would be equal to price, right? Only in that case, marginal revenue would be equal to price. But other than that, marginal revenue, as we said, that is going to be below the price. So if you sell an additional unit, the contribution of that to your total revenue is going to be less than its price. And remember, we discussed why. So now let's actually look at here and let's call this. So suppose if demand is elastic, then what's going to happen? What does that mean? If demand is elastic, what is this guy? If it's elastic, it should be a number like -2, -3, right? So the absolute value, so it should be it's always negative, we know, except for the given goods, but it should be less than what? -1, right? So here now, this is not the baby micro, there we mostly but here, right, so we want numbers like -2, -3, so this is basically this should be less than -1. Okay, then what's going to happen? So, for instance, you put here a number like -2, but what can you say about the marginal revenue? Marginal revenue is what? It would be, if I put there -2, what's going to happen? Marginal revenue, is it positive or negative? Marginal revenue. Positive, right? Because I put here -2, so it's -1/2, less than, it's going to be, right? So this portion would be positive, so this is positive. Then marginal revenue is positive, okay? So another one, we can say that if demand is unit elastic, then what is it? This elasticity is what? Is equal to 1 or -1, right? Then we said marginal revenue is what? If I put -1 there, marginal revenue is 0, right? So, fine. And then let's actually think about this guy, the third one. So if demand is inelastic, then this elasticity is what? Greater than -1, right? But as you said, less than 0. So let's put it like this: 0 QP. So let's put it like this, right? So it's going to be a number like -1/2, right? -1/3. So then, what's happening to marginal revenue? I put here, instead of this guy, for instance, -1/2. What happens? This makes -2. So this whole thing is negative, right? Okay.
Bir şey sorabilir miyim?
Yes.
Firm price taker'sa değişti neden oluyordu?
Huh?
Firm price taker'sa değişti neden oluyordu?
So he's asking if the firm is the price taker, then this derivative, why it is 0? Because that's the definition of price taker. Here, if the firm is a price taker, PQ is equal to P. It's not a function of Q, okay? Then if I take the derivative of this guy with respect to Q, if this is not a function of Q, it's just 0, okay? That's fine. So basically, so we said that marginal revenue is negative. So you see, elasticity is very important. Remember, we discussed this to figure out what's going to happen, right, for this firm. So now, what else we can say? Oh, so for instance, if demand is infinitely elastic, right? So let's say if demand is infinitely elastic, right? Or we call it perfectly elastic. So meaning that it has an infinite elasticity, perfectly elastic. If demand is perfectly elastic, meaning that this guy is minus infinity, then what's going to happen? Marginal revenue is equal to, what's going to happen? If demand is perfectly elastic, if this is here, it's minus infinity, this becomes 0. Marginal revenue is equal to price, right? So this we know, right? So this is, and if demand is perfectly elastic, what does this mean? If demand is perfectly elastic, what kind of a demand curve do we have?
Constant.
Right, so if you put here P and if you put here quantity, demand curve is something like this, right? A perfectly elastic demand curve is something like this. And this is what we say, the firm is a price taker, right? Because it doesn't, whatever you sell, you cannot affect the price, right? It's always, you can sell each unit at the same price, or to put it in some other way. So if demand is perfectly elastic, we know that, and it means that firm is a price taker. Suppose you're a monopolist, right? You know what is a monopoly, right? You're the only seller in the market. Suppose you're a monopolist. Do you think you'll ever operate in some portion where you have marginal revenue being negative, where marginal revenue is negative? What does that mean? It means that if you sell another unit, it decreases your total revenue. If you produce another unit, it's going to increase. Do you think it's going to increase or decrease your total cost? Increase, right? If there's some technology that I produce, right, more, and it's going to decrease my costs, don't forget that this is total cost, right? It might decrease my average cost, but it might not, right? It might not, but in terms of total cost is going to increase for sure, right? If there's any technology I keep producing and my total cost falls, that would have been great, but we don't have that. I don't think we'll ever have that, okay? But the issue is that, so here, it means that if you sell or if you produce another unit, the contribution to your total revenue is going to be decreasing, right? Sort of, the contribution is going to be decreasing. And when you produce another unit, your costs would be increasing. So according to the profit maximization idea, would you ever produce there?
No.
Yes, no, maybe. No, right? Because this is, you know that this is your profit maximizing condition, right? So if marginal revenue is negative, you have to set it equal to marginal cost, right? And you have to find a point where marginal cost is negative as well. But that doesn't exist, right? Right? So basically it doesn't make sense, like if I'm the monopolist, it doesn't make sense where marginal revenue is negative, right? I'm not going to produce at the inelastic portion of the demand curve. So I'll draw it, you'll understand what I mean here, okay? But you'll never produce there because it doesn't make sense, right? So if you produce in that region, when you increase quantity or for that quantity, right, marginal revenue is negative, then what should you do? You should right? You should decrease production, right? Because apparently marginal revenue you are producing in such a way that it's too much. It's not bringing you any additional utility anymore, right? Then you actually you should decrease your production, okay? So now you'll see what I mean. Okay, so now let me draw you a picture. Now you'll understand. So suppose we said that a firm faces a linear demand curve. A firm faces a linear demand curve. Okay? Now, what do we mean by a linear demand curve? It's a curve like this. Q equals to, let's say, A minus BP. Okay? So this is the demand curve. Okay? Remember? Demand curve that we got, right? Now, but whenever I draw this, if I want to draw this, how do I draw it? So if I want to draw a demand curve, I draw like this, right? I put P here, I put Q here. So what we draw was what? Remember we talked about this? Was the inverse demand curve, right? So that's what we call. So basically it's like P equals to something. So this is the demand curve. So if I want to draw it, I'm going to draw the inverse demand curve, right? Because that's the tradition, remember we discussed. So basically it's BP, right, equals to A minus Q, P equals to A over B minus 1 over B times Q, right? So what is the slope of this inverse actually demand curve? It is minus 1 over B, right? And the intercept here is this, right? So I can say this is A over B, it goes here, okay? So if I want to draw this, so basically this is, and this part is A, right? And slope is, as you said, Hocam, it's minus 1 over B, okay? Now, so this is the inverse demand curve. So this guy here is the inverse demand curve. Sometimes this is useful, sometimes this is useful, okay? We'll see. Now, okay, now let's try to figure out the profit maximizing decision, okay? So now let's try to figure out the profit maximizing decision, right? So let's actually have this. So what is, for instance, let's try to figure out what is total revenue if we have that kind of a demand curve. What is total revenue? You said that, Hocam, it's P times, right? So total revenue is like PQ times Q, okay? So if I write demand curve here, and then I keep this guy, then I have to keep this guy as P, right? Then it's going to be a function of P. That's why you need to, as I said, that from time to time, you're going to use either the inverse demand curve or the demand curve. Here, you need to use the inverse demand curve, right? The price as a function of Q. So then we can write this, right? So here, AB minus 1 over B, Q, right, times Q. So this is total revenue. So this is A, B, Q minus 1 over B, Q squared, right? So this is total revenue. What is marginal revenue? So let's actually have a look at this. What is marginal revenue? It's actually the derivative of the total revenue, right, with respect to Q. Now, let's do this. Basically, so what is, if I take the derivative with respect to Q, it's going to be A over B minus, right, 2B Q, right? So this is marginal revenue, okay? So this is basically, so this is the total revenue, expression for total revenue. This is the expression for marginal revenue. Do you see any relationship between marginal revenue and this inverse demand curve? What happened? They're parallel, or let's do this. So let's draw P. Their slopes are the same or no? So yeah, that's exactly what, so you see that if this is the demand curve, and this is, remember this we call the inverse demand curve. Okay, so this is the inverse demand curve, and we have, so let's call this D if you want, or if you want we can call it PQ. Sometimes this is also called the average revenue curve. Okay, sometimes they call it, this guy, also the average revenue. Why that is called the average revenue? What is average? So average revenue is, let's call it like this. So basically it is, let's call it ARQ, okay? And then this is going to be total revenue, Q divided by Q, okay? So total revenue, as you know, that it's PQ times Q divided by Q. So you see this inverse demand curve is sometimes called the average revenue curve, okay? So you call it PQ, ARQ, or if you want, you can call it the inverse demand curve, okay? Now, apparently, as you said, hocam, this is A over B, hocam, this is A. You said that, hocam, this is the inverse demand curve. If I want to draw the marginal revenue, it is, as you said, it has a slope, right? It has twice the slope of it, right? So its slope is minus 2 over B. And what is this point? What is this point? A over 2, right? So this is basically A over 2. So this is true for any linear demand curve. You can always say that, oh, this is a linear demand curve. Marginal revenue is going to be, if I want to draw the marginal revenue, it's going to have a slope twice as much as this curve, and it's going to cut it in the middle, okay? Now, so this is the case. Fine. Now let me try to figure out the profit maximizing point, okay? So suppose I have a, let's have a marginal cost curve, okay? Suppose I have, let me draw my average cost curve. Suppose this is my average cost, okay? And then suppose this is my marginal cost. So let's put it like this. Okay, bless you. Suppose this is my marginal cost, okay? So let me make this, but I know that marginal cost should go through the minimum of the average cost, right? So let me draw that accordingly. So let me do it again. So this is the marginal cost, so let's have it, okay? Something like this. So I made sure that it goes through the minimum, okay? So then, because that I know, that we figured out, then what about the profit maximizing condition? I know that firm is going to make marginal cost equals to marginal revenue, right? So what is marginal cost? Is this. What is this? This is marginal revenue, okay? So this is basically marginal revenue Q, okay? And then, so I know that this guy should be equal to this guy, okay? So I go, so this is the profit maximizing quantity. I put Q star, okay? And then this is going to be marginal revenue Q star, which is equal to marginal cost Q star, okay? But in order to find price, what I do is that I go up, okay, in the demand curve or the inverse demand curve, and this is going to be my price, okay? So this is basically, so sometimes students get confused and they say that, oh, hocam, they said, oh, they're equal here, so this is the price. No, this is not the price, right? In order to find the price, you should go up in the demand curve and then set it equal to, right? So then set it equal to that quantity to get the profit maximizing price level, okay? So then, for instance, here, I can show my profit as well. How can I show that? What is profit? Profit is total revenue minus total cost, right? What is total revenue? P star times Q star. So it's just this rectangle. What is my cost? What is my total cost? it's you can have average cost times Q, right? So basically, this is total cost. And then this is my average cost. I go and I check, right? So let's say so this point is average cost at Q star. So basically, average cost times Q star would be my total cost. Therefore, my profit is this area. Okay? This is my maximal profit. Okay? So this is basically, in general, this is a very typical picture if you want to understand any profit maximization decision. Okay? So this is basically where you have these guys. But don't forget that for any linear demand curve, no matter what A, B are, you are going to have a marginal revenue curve like this, okay? And then you can always show, like some sort of a profit maximization problem on a graph like this, okay? But you can check, you see that the profit maximizing point, remember what did we say? It's on the increasing portion of the marginal cost, right? So you see it's actually on the increasing portion of the marginal cost, which is here. It's not, so what I meant was this. Suppose you had a marginal cost like this, marginal cost curve like this, okay? So basically, or it could go up like this. So there could be another point where they're equal, right? But you would never operate on a portion where marginal cost is decreasing, okay? So this is basically the case. So just keep this in your mind. And from here, it's also obvious that marginal revenue would always lie below the inverse demand curve, right? So the price. Basically, it's going to be always, you see the curve is always below the price, okay? And also we can say that, remember I told you that a monopolist would never operate in the inelastic portion of the demand curve. So you see remember, and in the inelastic portion, marginal revenue was what? Was less than zero, right? So basically, the inelastic portion is going to be somewhere here. In this portion, you see that for these quantities, marginal revenue is negative. So you can be sure that a monopolist would never operate in this region, okay? So a monopolist's optimal quantity would always be in this region, okay? So with similar triangles, you can find that this portion is also equal to this portion, right? So it's very important to understand when we have this linear demand curves, what's happening, okay? Now, so just keep this in your mind. There is another thing that I want you guys to understand, and then we'll give a break. So, which is basically, so there is this thing called price marginal cost markup, okay? So whenever people are talking about markups and such, there might be, like other ways of expressing it, but one of them is actually this. So it's basically this. What we mean by price marginal cost markup is that you see that apparently firms are, but it will depend again whether they are price taker, whether they're a monopoly, whether there are too many firms out there, or whether there are few firms out there. So that matters a lot. But you see that apparently, for instance, from this picture, you see that whenever firms set the price, it's not their marginal cost, right? For instance, here, this is for a monopolist. So you see that it's above their marginal cost. So they put some sort of a markup, right? So they are not, of course, they want to make profit. So they're not that nice. So they don't charge you their cost, right? But they charge you more than that. So this is basically what we are wondering, right? So how much of price belongs to marginal cost and how much of price belongs to this markup, okay? So if you want to get this,
What's the markup?
Markup is basically it's the portion that the firm adds on top of its marginal cost. Okay, so as I said that because you can actually think of it as like per unit sort of profit, not exactly, but for each unit, right? So what portion of price? So the firm is charging this P. This portion of it is literally coming from its costs, but this portion of it is not costs, okay? It's not, it's being greedy and, right? So you know what greedy means, right? Açgözlü. So, okay, so it's actually part of that, right? So it's, so this is very important. For instance, do you think this markup, even before I put the math on the board, you will be able to say this. This portion, right? So suppose there are a lot of firms in that market. Do you think this markup will be more or less? Less, right? If there's one firm in that market, do you think this markup will be more or less? More, right? So you see with math, we're going to see that. But basically, so you see, for instance, have you heard, there is this authority called the Competition Authority in Turkey. Have you heard of it? Rekabet Kurumu. So you know what they deal with? They always deal with these kind of stuff. So they would like to figure out, because if the markup is too high, right, then is it good for consumers? No, right? And then so the competition authority is actually trying to figure, you know, like trying to protect on some end the consumers and on some end also some firms as well, right? So if there are like, suppose they become and they collude, so you know what they form a, let's say, a cartel and such. So the whole idea is to get a lot of profit, right? And then if they are the whole, suppose they become together, suppose Turkcell, Vodafone and Avea, they come together. Do you think the prices they will charge will be more or less? More, right? Because they're the only, there's no competition going on, so they're going to charge a lot, right? So how do we so this is really nice because we can know that this portion is due to costs and this portion is, you know, like due to profit, okay? Their desire to make profit. Exactly. So like he's right, but now we are, for instance, talking about like if you think of dynamically in the long run, yes, other people would come. But for instance, for the cellular phone market, it's pretty hard to enter, right? So there are some barriers to entry. So there are just many ways. As I said, the market structure is a complicated thing. So you have to check whether there are any barriers to enter, right? So whether, you know, like how much are the, for instance, fixed costs, if they're too high, again, it's a problem, right? If you want to build a dam or if you want to produce electricity, you say, oh, I'm going to enter the electricity market tomorrow, right? And start producing. You cannot do that, right? So, or for the cellular phone services, these are not that easy. Or sometimes these rights are given to the firms by law. For instance, probably you guys don't remember, but at some point, Turkish Airlines was the only producer of domestic flight services, okay? So they were the only provider of domestic flights. We didn't have Pegasus, Atlas Jet, Bora Jet, whatever, what else, right? Onur Air, right? So like we didn't have those, you know, like companies because it was prohibited by law that the domestic flights could only be operated by Turkish Airlines. There you go, right? So there's, you couldn't, so they were barriers to enter, okay? But otherwise, if there are no barriers for entry, actually we wouldn't have a monopoly, right? So this is basically the case. So you see that this is important, even though you see that elasticity, all these measures are important. So what I know is that marginal revenue, remember it was this, price 1, so this is QP, okay? So this is what we have found. So this was marginal revenue. We know that at the optimal point, marginal revenue should be equal to marginal cost, right? So basically marginal cost is this guy. Now let me try to write this. Then this is what? 1 minus marginal cost divided by P. 1 minus, right? So this is marginal cost, P, 1 plus 1 over elasticity divided by P. These guys go away. This one and this one go away. And this becomes minus 1 over elasticity. And if elasticity is negative, except for the given goods, remember, then this is going to be, I can actually write it like this. So you see that price minus marginal cost markup is something like this. And this has a name. So due to economist Abba learners, okay, this guy is called this price marginal cost markup. This is actually called the Lerner index, okay? Due to Abba Lerner, and then this is called the Lerner index. It means that, so you see that, so now we can actually figure this out. If elasticity is, if demand is very elastic, what is this? Price minus marginal cost. Suppose we have, for instance, the price taker case. Suppose we have the, basically which I erased, but right, where demand is perfectly elastic. Then what is this? When demand is perfectly elastic, what is this?
Infinite.
This is, right, infinity, the absolute value of it. And this guy would be 0 because price is equal to marginal cost, right? And you know that when we have perfectly competitive markets, the firm is going to be a price taker, meaning that there are lots of firms out there, okay? Many firms. So you see that when there are many firms out there, then you can think that when the competition is really high, that this Lerner index is 0, right? So you see that then when elasticity becomes sort of smaller, okay? So the more elastic it gets, apparently, what's happening to the Lerner index? It's falling, right? So the more elastic, the more the markup or the less the markup? The less the markup, right? So the more elastic, you can always think that, oh, we're getting closer to the perfectly competitive case. There are lots of tomato producers out there. They cannot affect the price. They're so little, they're atomistic, right? So the more elastic it gets, the lesser the markup. The less elastic it gets, right, demand, the more actually, the more the markup, okay?
May I ask something?
Yes, of course.
I was wondering the same thing done with marginal revenues compared to elasticity.
Huh.
Whatever we're producing.
Uh-huh.
So if it's inelastic, shouldn't it be that marginal revenue is positive? Because I didn't get like.
If it's inelastic, we said that marginal revenue is negative,
Yes,
right?
but let's say
Huh.
the good is, I don't know, coffee, and it's
Uh-huh.
so inelastic that whatever the price is, people still consume şöyle böyle the same amount. Yeah.
So, but then you are saying that, right? It's
if you just increase the price, and by price I mean the markup, so it won't change anything, and they will get more revenue.
it's okay. So think of it here, right? So for instance, if you're marginal, so here is the problem. You have to set, right, marginal revenue equals to marginal cost, right? So if your marginal revenue is negative, you need to find some marginal cost level which is negative, right? Or for instance, think of it like this. Suppose it's inelastic, okay? So suppose I put here 1 over 2. What does this become? It becomes 2, right? So this is 1 over 2. This becomes 2. What does this mean? I'm going to subtract something from marginal cost and then divide it by price, and it's going to give me 200%. Unless this is negative, it's impossible, right? So that's why it's not logical, because you can always decrease your quantity and increase your marginal revenue, okay? Therefore, you would never operate in any portion where things are inelastic, okay?
Perfect.
But what you are saying is this. So he's saying this, Hocam, we have this PQ and I have a perfectly inelastic demand, right? So then, of course, you can set the price as much as you want, and then you're going to make infinitely many profits, okay? So that's what he's saying, but you see that here, do you decide on quantity? No, right? So it's fixed. So basically here we're talking about, where you decide on the quantity, okay? So in this case, yes, you don't decide on quantity, and then you can just set, like price as high as much. But usually that's never the case, right? It's a little bit.
Su 50 kuruşken yarın öbür gün 75 kuruş yapılsa genel şeyde konuşuyoruz.
Hı hı.
Gerçekten çok büyük bir değişim olacak mı? Çünkü su ne kadar etkilenecek mi?
So for instance, he's talking about water, and but you should think of it like that. It's not that easy. So up to some point, water is very essential for you, but after some quantities, you don't care, right? So, but these questions are, very valid questions, because whatever we talk is mostly, like ideal cases and these. But we are pretty good at explaining what's going on. But of course, they might not fit perfectly to, some of the stuff that we observe in real life, right? So, but these are very valid questions, okay? So let's just give a break for 5 minutes, and then we'll continue so that you guys can breathe, okay? Okay, so let's continue. So what we will do is that, remember in the very beginning of this course, I actually promised you to show where the demand curve, right? So we had the demand curve and the supply curve, where those curves were coming from, okay? So we dealt with the demand curve, as you remembered, right? So this was our demand curve, right? So we said this is the demand. So we figured out where this comes from, right? So we did all these utility maximization problem, expenditure minimization stuff, Hickesian demand, Marshallian demand. Now we know where this comes from, why it's downward sloping, under what conditions it won't be downward sloping, and such. And then my other promise to you was to actually explain where the supply curve was coming from, okay? Yes. So where the supply curve is coming from, right? I promised you, but I haven't kept my promise yet. I will. Okay. So where does this guy come from? Obviously, you can guess that, hocam, this is coming from the profit maximization problem, okay? And then yes, it's coming from the profit maximization problem, but you'll see that. Remember, we said that it's very important for firms to distinguish between short run and long run, okay? So you'll see that the short run supply curve, okay, and the long run supply curves, they would be different. They will come from the profit maximization problem, definitely. But in one case, remember in the profit, you're going to maximize your profits, but you would only change your labor. But in the other one, you can change everything, right? So basically, this is, so the supply curve will be a long run supply and a short run supply, and then I'll show you where this comes from, okay? So the first thing that we will be dealing with is that we're going to deal with the short run supply curve, okay? So, and we're going to do this for a price taking firm, because it's much easier to show stuff, okay? But you guys know the difference between short run and the long run. What was the difference between the short run and the long run? It's the fixed cost, right? So basically, whether you can change all the inputs or at least one of the inputs is fixed, okay? Now, let me write this. So let's have this so that you would have nice notes. Short run, okay, supply decision by a price-taking firm. And let's see whether we can get that kind of a supply curve, okay? So what is the short run supply decision by a price-taking firm? Meaning that what is Q, right? So we said that the Q is going to come from the profit maximization problem. We said we're going to take the derivatives, it is equal to 0. It should be on the increasing portion of marginal cost. We said those kind of stuff. But, right, so we said those stuff, but I still haven't told you what is Q, right? So now, or what is the supply? Supply basically for any price level, how much you're willing to supply, okay? So we said that suppose the firm is a price taker, okay? And then let's have this. So basically, I'm going to have this, okay, P, Q, and then let's actually have, I'm going to have my curves. I'm going to have my, okay, so I'm going to have my short run average cost curve, short run average cost, okay? I'm going to have my short run average variable cost, okay? So where do you think that curve should be? Below or above? Short run average variable cost. Remember, total cost was what? So let's write this. As you said, it should be below, right? So what is this? So remember, we said that in the short run, total cost, you can call it short run total cost, is basically variable cost, right? So there was fixed cost, and plus you can have variable cost, right? Or if you want short run variable cost, okay? So basically this is, and the average variable cost is when you, short run average variable cost, when you divide these guys by Q. So we call this average short run average cost. Let's call it like this, okay? This is going to be called short average fixed cost, and this is going to be called short run average variable cost, okay? So therefore, if this is short run average cost, short run average variable cost should be below, right? But when I draw it, how shall I draw it? Shall I draw it like this, just parallel, like this, or it should be different? Parallel, or what do you see? What's happening here? This is some number fixed. As I keep increasing Q, this becomes smaller and smaller. Therefore, these guys come to, right, converge to each other, right? They come closer. So if you want to draw a proper cost curve structure, you should draw it like this. Okay, short run average variable cost, right? Now, I'm going to draw my marginal cost. How shall I draw it? I'm going to draw my marginal cost. How shall I draw that? Where should that pass through? The marginal cost should be minimums of both of them, okay? Because you can just prove it very easily, right? Because this is a fixed number. So remember, marginal cost was actually when I take the derivative of this guy, and then in the short run, basically the only thing that is changing is actually the variable cost, right? You can only change Q by changing L. Therefore, the marginal cost in the short run is basically the derivative of the short run variable cost, right? And in the long run, in the marginal cost is going to be, right, so going through both of these guys, the minimum of these guys, okay? So it's something like this. So let's have it like that. So suppose this is the marginal cost, okay? So this is the short run marginal cost, okay? It goes through the minimums. So what is marginal cost? We know that marginal cost was passing through what? The minimum of the averages, right? So it doesn't matter whether it's going to pass through. So the minimum, it's going to pass through the minimum of this guy and the minimum of this guy, right? But of course, because this has this fixed cost in it as well, it's going to be a little bit, the minimum of that is going to be a little bit here, okay? So that's why. So basically, so this is the marginal cost, okay? So let's actually have the marginal cost like this, and you can have these cost curves like this. You'll understand why I said that. Now, suppose the firm is a price taker. Suppose the price is P star, okay? So let's say this. Suppose market price, yes,
Variable cost derken ne demek?
variable.
Variable cost derken ne demek istiyorsun?
So variable cost, it means that it can vary, right? So remember, in the short run, we had capital and labor, right? So we said that in the short run, capital was fixed. Whatever K you have, it's fixed. But your labor, you can change. So if you want to change your output, actually, if you want to change Q, F of L, K is fixed, you can only change L. Therefore, the variable cost, for instance, in this model, is only the labor cost, okay? So the variable cost is that if you want to change, when your output changes, that cost changes, okay? But the other one, fixed cost, it doesn't change, okay? And because it's harder to show the totals, we want to show the averages. That's why we plot the averages, right? Averages are easier, okay? So now, let's suppose the market price is P star. We said that this firm is a price taker. Then the demand curve that this firm faces is what? The price is this, right? So let's put it here. Okay, so let's call this P star. Okay, so this is what? P star, if the firm is a price taker, P star is equal to what? It's equal to marginal revenue, right? As you guys told me, hocam, it's equal to, let's put it here. So this is, that's short run average cost. This guy is short run average variable cost, okay? And then here we know that this is the demand that this firm faces, demand for firm. But at the same time, this is marginal revenue. This is equal to price, right? It's equal to average revenue, whatever, okay? So this is basically the case. So now, so we have this, and we also said that, hocam, this is also equal to average revenue, right? You guys told me. And then where is the profit maximizing point? If the firm is a price taker, it's P price equals to, it takes the price as given, equals to marginal cost, right? So basically, let's see. Price equals to marginal cost, it's here. So let's call it Q star. So this is the profit maximizing quantity. So if I want to show the profit, you see that at this Q, the cost is this much. I go here. So this is the short run average cost at Q star, right? Because we know, right, we discussed this before. So this portion is going to be the profit. Is it positive or negative? Profit is positive. Why? Because price is right above, as you see, so the cost is this much. So this is positive. Suppose the price level was this. Suppose somewhere here. P double star. Okay? Again, this is average revenue, marginal revenue, price, demand for firm. Okay? So let's say, suppose, so here this goes to Q star. Okay? Suppose market price is equal to P double star. Okay? So basically, then you're going to set P double star equals to marginal cost, right? So let's call this Q double star. So this place is where? So the optimal quantity is here, Q double star, right? Then what's going on at Q double star? At Q double star, price is this. So the money that you earn, your total revenue, is this guy times this guy, basically this area. What about the cost though? I go up in here, right? So the cost is somewhere here. Short run average cost Q double star here. So where is the profit? Is there a profit? This is what we call economic profit, economic loss, okay? As you said, the hocam, this is the money that he earns, but this is the cost. So this portion in between is the loss, right? So it's negative, basically. Profit is negative, right? So you see that it's here profit is positive, here profit is negative, okay? So let's put double star. Do you think this guy would operate there?
Yes.
Why?
He's covering a portion of his fixed cost.
So this is actually, so this is, you see, whether you would like to supply or not in the short run, and actually in the short run you might decide to shut down. Dükkanı kapatıp gitmek isteyebilirsiniz, okay? But how do you decide on that? How do you determine that? Is according to this logic. If, suppose you have a firm, okay? Your grandma, now we missed her, right now she's back. Suppose she gave you her house, okay? So that, and you have a firm with your dad, and suppose you don't pay rent to your grandma, okay? In economics, even if you don't pay rent to your grandma, we include the cost of that, right? Using that apartment, its best alternative, the cost of its best alternative use in the cost, okay? So therefore, your grandma, even you don't pay her anything, we would consider it as economic cost, okay? Suppose your grandma gives you the house, you work with your dad, you have a few friends, you have a firm, you can pay your friends money, you can pay electricity, you can pay all the costs, you can even get some money and your dad can get some money, but you cannot give money to your grandma. Would you consider, like shutting down, or you would keep operating? You would keep operating, right? So because what we see is that is part of, right? So your grandma gave you that house, that flat, whatever, apartment. So it's part of the fixed cost, right? But what you can do is you can cover your variable costs, okay? So as long as you can cover your total revenue, don't worry, we'll come to this again, but as long as your total revenue covers your short-run variable costs, okay? So what did I call? Yeah, short-term variable costs. Then you'll keep operating as you do here. Because here the loss that you make is what we call an economic loss. It doesn't mean that you're not earning money, your dad is not earning money. It's just that you cannot pay the rent to your grandma, but she gave it to you anyways, right? So she didn't want any rent. But in terms of economic cost, we have to include the cost of that house, okay? Because we include the cost of that house, and that's going to be part of fixed cost, it would look like as if you're making a loss, but you would still be operating, okay? But if your total revenue cannot cover, suppose you have a firm, your grandma gave you the flat, you cannot make money, your dad cannot make money, and you cannot pay one of your workers. Would you keep operating? No, right? That doesn't make sense. I mean, you cannot even cover the operating costs. You cannot even cover you cannot even pay your, laborers, your workers, their salaries. Then it doesn't make sense. Then you should shut down, okay? So this is actually in the short run how firm is going to decide. And you'll see that I will come to this again, but you'll see that it turns out that the supply curve, whatever the price is, you see the marginal cost determines how much you produce. So we're going to see if you want to produce, your supply curve would be your marginal cost curve. If you don't want to produce, your supply would be 0, okay? But I'll come back to this again in our class on Tuesday.